Welcome to solverfy.
Okay, so for this problem, you have a solenoid and you're interested in the electric field somewhere outside the solenoid. And then the current through the solenoid is varying sinusoidally with respect to time. So again, we're going to use the integral of E dot ds, where this is a line integral around some surface, and we'll let our surface be a circle which intersects which is concentric with the solenoid, and that's going to be equal to minus d flux dt. And working on this left side, that's going to be e 2 pi r, where r is the radius we're concerned with. And then over here on the right side, it's the change in magnetic flux, so that's going to be so the area, so flux is BA, the integral B dot dA. B stays the same spatially, so it's just BA, no integral needed. And so we wanted, the area doesn't change, so we just want to take the time derivative of the magnetic field. So we're told that it oscillates sinusoidally between 29.6 and 30 Tesla at 15 hertz. So we can say that it's 29.8, but you could tell what I was going to say next. 29.8 plus 0.2, and let's just say cosine omega t, where omega equals 2 pi f, and they give that f is 15 hertz. And so there's our b, and then the time derivative part is all contained here. So that's just going to be a times 0.2, and then the derivative of that is, we'll get a factor of omega, and then sine omega t, and then I guess I'll keep this negative here, and the negative goes away there. Yeah, and then area is pi. So we want the area that's intercepting flux, which involves the cross-sectional area of the solenoid. And so taking that into account and just isolating E algebraically, we got E is 1 over 2 pi r times pi r the solenoid squared times 0.2 times omega. And then we want to get the amplitude. So we just can cut this sine omega t part. So when I plug this into a calculator, oh, by the way, these cancel. Let me make sure I wrote everything that you would need to actually put this into a calculator yourself. So on the top, you have this R the solenoid. Let's write down what that is. The R the solenoid is 3.3 centimeters divided by 2, because they give you the diameter. And the radius that we're interested in is 1.6 meters. So centimeters. So then R is 0.016 meters. And then plugging all of that in, I'm going to just double check all my work. So 0.5, half of 3.3, 10 to the minus 2 squared, times 0.2 divided by 0.016, and then we need to multiply by omega, which is 2 pi f. I obtain 0.16. Oh, what a funny zero. Why did it do that? Volts per meters.